Good afternoon, everyone. Thank you for attending Session 7 of the IBR Webinar Series. As a reminder to all participants, this webinar is public and is being recorded. The registration information was posted on the NERC website and widely distributed. Speakers on the call should keep in mind that the listening audience may include members of the press and representatives of various governmental authorities, in addition to the expected participation by industry stakeholders. Should you wish to ask a question during today's webinar, please use the Q&A feature. It is NERC's policy and practice to obey the antitrust laws and to avoid all conduct that unreasonably restrains competition. This policy requires the avoidance of any conduct that violates or might appear to violate the antitrust laws. Any NERC participant that is uncertain about the legal ramifications of a particular course of conduct or who has doubts or concerns about whether or not NERC's antitrust compliance is implicated in any situation should consult NERC's General Counsel immediately. At this time, we'll hear a few words from Alex Sheddick.
Thanks, Lavitra, and welcome everyone to our 7th webinar session here. We have a good set of presenters today. We're going to talk about EMT and special studies and how those fit into the interconnection process. I think that's it. We'll keep it short. We have a lot of good presentations here, so we're going to jump right into our first presenter, Andrew Isaacs.
Oh, can you hear me, Alex?
Yes, we can hear you, Andrew.
Thanks, Lavitra. All right, I'll just introduce myself really quickly. My name is Andrew Isaacs. I'm a vice president at Electronics Corporation. We're a consulting company based in Winnipeg, Manitoba, in Canada. We offer consulting services in, studies and simulation mainly. Our founders were the original authors of the PSCAD simulation tool, which is one of the more popular EMT tools. Although today we're not really talking about anything specific, we'll be using EMT in a general sense as it applies across the board. So today I wanted to talk about, just have a very short presentation. We're going to introduce EMT studies in general. What are they? What have they been? Where are they going a little bit in the future? And it'll be a fairly general look at it. Go ahead and start the next slide if you don't mind, Alex. So I wanted to sort of level set by saying first of all, why are we using these new tools, electromagnetic transient tools? Just to make sure, I'm sure it's been said in the past, but EMT stands for electromagnetic transients. We're really, it's a category of tool which is more detailed than the traditional planning tools such as transient stability tools or phasor domain tools. And the reason why we need them is to get something out of our studies that we can't get with our existing tools or with other tools. So wherever we don't have sufficient accuracy in our tools or in our studies, we add EMT for certain types anyway. So some of these phenomena are very difficult to predict, reliability issues that are hard to predict, or design issues, and we'll go into some of that using traditional tools. And in particular, the transition to inverter-based generation that we're seeing around the world is challenging our ability to predict outcomes. And we have events that have been documented by NERC and others that are reinforcing the need for these advanced studies and tools. And so the recommendation for increased use of EMT has come out of NERC recently. And using those tools, these advanced EMT tools, we are catching issues every day before the projects go in service. So there's a reason why we're using them. I just wanted to note also that we don't always need EMT. It's quite scary, especially planning groups who have not been using EMT extensively for dynamic performance studies. The idea of replacing all of our existing tools with EMT is not what we're talking about. We're using it as a supplement for existing tools. Next slide, please. So if I can sort of bucket EMT studies and EMT tools in different ways. I would say the first bucket we could put electromagnetic transients into is what I would call classic transient studies. So this is the kind of studies that really the tools were designed for 50 years ago. In the 1970s, people were designing the first algorithms and the first commercial tools and non-commercial tools that were able to look at transients at a degree that they weren't in the past. So some subcategories in what I would call classical studies would be looking at effects of lightning, of transient overvoltage or transient recovery voltage, switching of lines, faults, transients to evaluate arrestor energies, doing insulation coordination. I've got a picture on the right-hand side here of what it looks like when you have a breaker on a capacitor restrike. So essentially a breaker fails to operate correctly, and you get this transient. What happens is you get a very fast transient that kind of rings down the line, and you can see the plot on the bottom is a zoom of the plot on the top, and you can see that if you look at the voltage all along a transmission line, you can see how that transient propagates down the line and reflects and bounces in different ways, and actually also interacts with the transients bouncing around on the other two phases, on the normal phases. And then using that tool, you can find out what is the peak voltage that you might see on that line, so that, for example, you can calculate the minimum approach distance for a live line worker. So this would be one application of an EMT tool in a classical sense. Generally, these models are very high bandwidth, so you need to have the frequency dependence of the lines. You have to have a lot of detail, especially for things like a lightning study. You model things in a lot of detail in the substation. IBR models like a solar plant or a wind plant are often simplified or even neglected in these types of studies. And the extent of the system model is also quite small, so you can run these models on ordinary computers. And these are the types of studies that many people think of when they're talking about EMT studies. And many of you on the call and or people will have looked at these types of studies in university and be aware of them to some extent. So we'll call these classical transient studies. Next slide. Then we have a category of what I would say are special studies. So these are, you have a specific thing that you need to figure out. So it might be validating a protection, currents coming out of an IBR, or looking at control design of an HVDC link, or maybe you're doing harmonic studies in a region, or I've got a picture in the bottom right-hand side of a supercomputer, essentially a real-time simulator, which is another category of EMT where you're testing hardware, actual control hardware or protection hardware against a simulated network. So these models vary widely, and they're really very specific, and we're not going to talk about them much today. Next slide, Alex. And then the one that we're really driving at today, and also which is kind of the focus of a lot of the NERC guidance coming out recently, would be what I would call dynamic performance studies. So these are not new. We've done these for years in special circumstances. And certainly you do a lot of dynamic performance studies with transient stability tools and conventional planning tools. But this is a new focus on EMT, driven really again by the energy transition. So that the transition to renewables and inverter-based resources. Subcategories in this group of studies would be weak system performance, subsynchronous oscillations for series capacitors, control interactions between different IBRs. If you're concerned about fault ride through in challenging areas, or recently performance capability verification of IBRs against standards, new standards coming out, or even replicating events in detail that caused ride through failure. This is new, or at least a new focus for EMT studies. So on the right side, I've got an example of what that looks like when you're modeling a big system or a big region of a power system with lots of IBRs. You're concerned if these things aren't riding through normal faults. So You can see what that looks like in an EMT tool. Your active power drops off in the top plot. Reactive power does something during the fault and then goes to zero. The voltage is recovering normally. And then you've got some trip signals. And then, the trademark of an electromagnetic transient tool is you can see the phase voltages, the voltages and the currents. So you can see what happened there. The current, the plant didn't trip off until the fault cleared, and then there was some transient, and then the currents ring away and the plant is gone. So this is what we're looking at with these ride-through studies often. So when you're doing these studies, you're using a much more extensive model often. Varying extents, I would say, but they may be quite extensive, requiring really large sections of the power system. And you may require more powerful computers. These types of studies generally are now what I referred to in the first slide as supplementing or overlapping with conventional studies and making those stronger. So the transient stability studies that your planning groups are all doing may begin to be supplemented by these types of studies. Next slide, please. I just wanted to highlight sort of the extent that these models are growing. So in the past, when we're doing these classical studies, we're doing really, relatively simple system equivalents. No longer simple. I've just got a couple of examples for reference of the sizes of the studies that are currently being done. These are routine studies that people are running around the world, including in the US. So now there are, many, hundreds to thousands of buses, many detailed models, varying degrees of complexity in the loads and so on. So this is still, for reference, still much smaller than the models that have been used in transient stability domain, the phasor domain tools. The Eastern Interconnect, for example, has, I think, 84,000 plus or minus, thousands and thousands of plants, not even including the distributed resources and lots of loads. So, this is an indicator that we're not done with phasor domain tools. We still need those, but the size of the EMT models are growing. Next slide, please. So the focus of some of these guides that are coming out from NERC and recommendations from other groups as well is on IBR model requirements. This is something that's a big input to these studies, and so it's very important that they get that they're correct and useful. The accuracy needs to be there. They need to be usable. Do they fit within a study? Validation is becoming, a more important topic of the models. The models have to be parameterized appropriately to make sure they're correct. It's not, automatic that you get a correct EMT model. It needs to be parameterized. And then, of course, we need the plant to conform with the standards from the local region or from international standards like 2800. And then, of course, we have a lot of work to do on the system modeling and the study processes side too. We have to be able to handle all these models together and put them into a usable system model so we can actually do analysis. And that needs further advancing, but that's coming. Next slide, please. I just want to leave you with a couple of key messages from this very short presentation. EMT is not new, but the renewable transition that we're all going through is driving a wave of new requirements for EMT studies. And this is based on, the need to keep the grid reliable. They've been effective in improving those studies in the past, and we think that will not go away. It will become more important. The EMT models need to be really detailed and correct. We can't get away with, phoning that in any way, because the studies then become less useful. And since the studies are a lot of work and a lot of effort and a lot of time, we don't want to waste our time with those. And so right now, at this stage of the sort of adoption of EMT modeling, we're really focusing on EMT IBR model quality. And I just want to leave you with EMT models are a fact of life in our future in the power system sort of engineering community. I would encourage those of you in sort of management or directing these processes. This is the time to invest in simulation hardware and software, invest, especially in people. This is going to take extra resources. It's not something that you can tag on generally to the existing workload of people. So you need to add people to the teams that are doing these studies, and then you need to train them, invest in knowledge. There's not enough people out there right now who can do all of these studies. We need to develop those people. So that has to happen in the coming years. And then, of course, we have to get started on processes, on regulations, on rules, on criteria. And then immediately begin implementing these recommendations coming out of NERC to collect models and check them for correctness and all these things that we talked about. That can happen immediately if it hasn't started already. I think that's all. Turn it over to the next presenter.
Thanks, Andrew. I'm just leave your contact info up here just for a second while I introduce Andrew Arana, the second A of our 3A presentation panel today. Who's going to talk to us about Florida Power and Light and their experiences.
Thank you very much, and good afternoon. My name is Andrew Arana. I'm the Director of Florida Power and Light's Real Zero Systems Planning Group. My team is focused on realizing FPL's vision of a carbon-free electric grid. We perform studies to ensure that as the penetration of inverter-based resources increases, that they don't have a negative impact on reliability or power quality. We're also tasked with analyzing new technologies which can mitigate these impacts. Increasingly, we're also relying on EMT analysis for these studies more and more. Andrew Isaacs just gave us some of the principles of EMT analysis and some general use cases. In this presentation, I'm going to build on that by providing some specific examples of what we have done here at FPL. Next slide, please. So Florida Power and Light currently has approximately 4,000 megawatts of solar installed and 500 megawatts of batteries. But our resource plan calls for us to increase those amounts six-fold over the next 10 years. By reference, our peak system load is currently 27,000 megawatts, and we're planning to have almost 24,000 megawatts of solar by 2032. This means that the instantaneous penetration of IBR will exceed 90%, many times throughout the year. Obviously, this is a major challenge, a major shift from our current system, and we're dealing with the same issues as the rest of the industry. Our interconnection queues are long. Our modeling and study techniques, which worked well forever with synchronous generators, are no longer sufficient. As inverter-based resources are proposed in more remote areas, we are seeing lower and lower short circuit ratios. Increased electrification is driving new types of loads in our system, such as EV chargers and hydrogen electrolyzers, things that we need to model in more detail and better understand. But where there's a challenge, there's also an opportunity. NERC's disturbance event reports and recommendations have been invaluable for us in understanding issues that have occurred in other regions and in getting ahead of those same issues in FPL. We perform our own detailed studies to understand our vulnerabilities to these issues that were described in the event reports, to identify system-specific challenges, determine the most effective solutions as well. Also, we look ahead, and as we imagine the system of the future, we work with our vendors, our partners in the research institutes, and we ask what inverter capabilities do we want going forward, rather than just limiting ourselves to planning the system around the inverter capabilities today. Next slide, please. So why do we need special studies for inverter-based resources? Why can't we just capture all of these can you go back? Yeah, right there, thank you, yeah. Why can't we capture all of these reliability issues through interconnection studies and annual planning assessments? One reason is that detailed EMT analysis is very time-consuming and is currently infeasible and, quite frankly, unnecessary to do them for every proposed generator. At Florida Power and Light, we perform these studies when the weighted short-circuit ratio is less than 3, or if we have some other reason to be concerned about controller interactions. We also perform studies for disturbance analysis. Fortunately, we haven't had any major events, nothing that would, necessitate a NERC event report or anything like that. But even when you have a single plant misoperate and there's minimal reliability risk to the bulk electric system, you still need to perform a study. We need to collect data. We need to fully understand what happened. We need to identify mitigations and roll them out to all applicable units. And we also need to assure that our studies can capture this issue going forward. We have performed studies with high penetrations of IBR to identify future grid impacts. Some of these studies include speculative generation that would not be captured in interconnection studies or annual planning assessments. We have identified reliability impacts that can be proactively mitigated through changes to our FAC1 interconnection requirements, effectively raising the performance standard of IBRs. For some reliability impacts, we need new solutions that we don't currently have at Florida Power and Light. And I'll give an example of those in the coming slides. And there have also been some cases where we have to modify protection settings at existing solar plants or even existing synchronous generators as well. Next slide, please. So a few years ago, we commissioned a PV plant in a relatively weak area of our system. It worked well for a few months, and then when a nearby transmission line was taken out of service on a planned clearance, we started experiencing high harmonics and flicker. Through offline studies, we were able to recreate this phenomenon. We were able to recreate a resonant condition with elevated 5th and 7th harmonics. We worked with the vendor on plant setting changes to mitigate this issue. And we also performed studies to assess this risk at other IBR sites. We also required monitoring and alarming at future IBR sites. So going forward, we can detect this in real time immediately. Our offline studies led to a full understanding and comprehensive solution to this problem. Next slide, please. So we had a proposal to interconnect a PV plant to the low side of a GSU at an existing combined cycle plant. The interconnection study for this new PV plant demonstrated that there were no load flow, no short circuit, or no transient stability concerns. The weighted short circuit ratio was well above 5, since it's right next to a large conventional plant. But we had never done this before. We were concerned about torsional interactions that could potentially damage the generator shaft. Therefore, we performed a detailed EMT analysis. We validated all the models, benchmarked our transient stability analysis results, and we performed things like SSTI, subsynchronous torsional interaction analysis, that we couldn't do with other tools. And we were able to demonstrate that there was no risk to the plant. Next slide, please. So I mentioned earlier that we've been seeing requests for solar in remote areas of our territory. In this particular case, we have 8 PV plants proposing to interconnect to a long radial line. Once again, there were no issues when we looked at this in load flow, short circuit, or transient stability analysis. However, in EMT analysis, we saw oscillations for normally cleared faults. We also had events on adjacent lines that led to tripping of these PV plants. We would have missed some of these performance issues if we didn't run the EMT analysis. So we developed both conventional mitigations and what I consider novel solutions to these reliability issues. I should mention first that the first thing we tried in EMT analysis was to modify the inverter settings. We adjusted the K factors, we adjusted the protection settings. We even adjusted the switching frequencies and tried a number of other things. None of that was effective. And in this case, the short circuit ratio was very low, so we're not surprised that those were not effective. One basic solution, Alex, if you can give me a mouse click. One basic solution is building additional transmission lines. This is effective. It mitigated the stability issues, but building a long 230 kV line was the most expensive solution we considered. Next click, please. Another solution is to install a synchronous condenser nearby. This improves the system strength, it relieves stability concerns, but it's also an expensive solution, especially for a situation like this where we didn't have any voltage issues. We didn't need the reactive support. We were installing the synchronous condenser solely to improve the system strength. Next click, please. Another solution we looked at, another solution that was proposed was series compensation. And this may also be a viable solution. We haven't looked at it in detail yet, but obviously I have concerns about SSR, subsynchronous resonance. This would have to be studied in detail. Another click, please. An emerging solution, which is one of my favorites at this point, although it still needs to be vetted more, is grid forming inverters. We performed initial analysis with EFRA's generic GFM inverter models in both PSSC and PSCAD, and we found that it eliminated our performance issues. And we expect that this will be way more cost effective than all of our other options. We still have some work to do here. Do we require GFM inverters at all eight PV plants, or do we only need them at a subset of those plants? Or is it better to install a standalone battery with GFM controls? And if so, what size should that battery be? Either way, we found that the generic models were very useful in the initial studies just to validate that this was a feasible solution. If we go forward, the next step will be to work with the vendors and to require the GFM models for the actual equipment that will be installed, and then we'd repeat these studies. One of the main takeaways that I want you to get from this slide is that we have conventional solutions in which we modify the grid to accommodate IBR, but we also need to keep pushing the envelope with the inverters themselves. And we need to provide feedback to our vendors on the capabilities that we're going to need going forward in order to avoid some of these expensive transmission level solutions for stability only issues. Next slide, please. So this was a very quick overview of some of the special studies that we have done. I hope it demonstrated the value in ensuring reliability, determining the best solutions. Our team here, the Real Zero planning team, is expanding. We're going to be doing a lot more of these studies. I expect that we're going to be doing them so often that we won't be able to call them special studies going forward. And much like Andrew Isaacs just said, these studies are going to be a fact of life going forward. So thank you for your time, and I look forward to your questions at the end. Thank you.
Andrew, very good presentation. Lots of good examples, and it's nice to hear there's a region going ahead with these and doing these special studies, and witnessing firsthand through your examples the benefit of doing them. And then also very nice to hear the going back and redoing them with the technology specific model is also very important. It sounds like you did the perfect use case for using a generic EMT model to prove concept, and then just checking your work with a OEM specific model. It's kind of the exact use case Nerk's been mentioning to the industry. So very good to have that example in here with your presentation. So thanks, and we'll see you in the Q&A. And now we have On, which is our third A of the day, who's going to talk to us about the EMT reliability guideline and the EMT task force. So On, take it away.
Thank you, Alex. So it's been a really good panel so far with the presentations, highlighting starting from the basics of EMT to the really good use cases examples by Andrew, and laying a really good ground for this topic here. Back in March of this year, we published the reliability guideline on EMT modeling for BPS connected IBRs. It really lays the ground for collecting a really high quality EMT model. And as Andrew mentioned, the quality is the key here, otherwise it defeats the purpose. And how do you verify those models once you collect it? And what do you do with them? So next, please. Next. So first we'll collect EMT models, right? So we'll try to quickly walk through the one of the life cycle, right? Would be let's collect EMT models and let's vet the models. And next would be to use the models to assess the plant performance, as well as also to to verify the quality of the models. And next, please. And then, that's during interconnection stage. Now, once you get closer to the pre-commissioning, then make sure what you study is what you get. Right? So that means making sure the equipment that is being installed and commissioned in the plant is configured as has been studied. Next, please. So once plant's commissioned, once it's in operation, use the field data to validate and improve the models or the plant as needed. So that will complete the loop for the EMT model for that plant. Right? So once that's done, we can say we've got a good model to be used in future planning studies and interconnection studies for newer plants. Next, please. So let's try to visualize the EMT modeling adoption across the industry in different stages. So stage one would be first, well, we got to first require those EMT models. And the second stage would be to verify those models that we collect as part of the new requirements. And the stage three would be to use those models once the quality has been vetted, once we know that the clear chain of custody has been established with the model and the equipment, is to use those models to do model-based performance assessment. Next, please. The stage four is for TPs and PCs to have screenings and in place to determine, okay, now that we have the vetted EMT models, and now that we assess the plant performance, what do we do with these models, right? So the good use cases that Andrew mentioned earlier, right? There will be special needs for these models, and just have these screening criteria in place, and also have processes improved to integrate these studies. And stage five, next, would be to use these models routinely and commonly to conduct interconnection and planning studies wherever it's deemed necessary. So next, please. So stage five is, as highlighted in the Odessa disturbance reports and the 2021 California disturbance reports, they're driving the need for the EMT modeling adopted as in the reliability standards, right? So there's an EMT SAR project 2022-4 going on, and that is pushing us towards the stage five. And to prepare for that, we have published this guideline tackling the first three stages. Next, please. We're currently working on the newly formed EMT task force is currently working on the part two of that guideline, which will focus more on the stage four and stage five. Next. Next. Our goal is, having gone through the first three stages, we would cover most of the risks that we've been identifying in the disturbance reports, such as instantaneous trippings, PLA loss of sinks, phase jam, and balance, AC/DC protection tripping, DC over voltage tripping. Most of these could be caught in the stage three assessment. So, the guideline that we're talking about today, chapter one covers it's recommended EMT model requirements. We even provided a sample checklist. Chapter two covers principles of model quality. So we're really trying to align our industry on the expected requirements, expectations around what it means to be model quality, and how to verify those model principles of model qualities using attestations and documentations to establish that, as well as unit model validation reports. Chapter three gets into the model adequacy test, functional tests, and disturbance breakthrough performance tests. So you can see they loosely model after the first 3 stages. And we try to get into a little bit into the stage 4 by covering the EMT study use cases, common situations needed in the EMT study. Next, please. Yeah, just keep going next. A couple more. Thank you. So just to visualize, the approach by different function entities. So what you've seen is pretty much in the realm of TPs and PCs, and obviously there are other entities involved, the GO and OEMs. So once TPs and PCs establish the model requirements, that GOs will use these to develop the plant models with the input from the OEMs and submit that as part of the interconnection package. And then TPs, PC will basically go through the entire process. Along the way, as we'll see later, there are a lot of opportunities to improve the model requirement itself as we learn more, as we do more studies. Yep, next, please. Just to quickly go over some of the very highlights of the paper, of the guideline. Well, first of all, establish EMT modeling requirements for all new IBR resources. Basically, that means require and collect and vet and test EMT models for all new IBR plants. Have a checklist of EMT model requirements for GO and equipment manufacturers so that all parties are on the same page. Require high quality EMT model as a prerequisite for interconnection. Require that those models accurately represents all pertinent controls and protections that can potentially affect the electrical output of the facility during and after the disturbances. Require all models include attestation by the OEM, attestation by the GO that the aggregate model represents the entire plant, and it includes various site-specific models, settings, protections, and controls. Include change management requirements and protocols to deal with changes that should be reflected in the EMT models by the GO, and clearly define the preview and duration of the EMT simulations. Next, please.
About 3 minutes left.
Sounds good. So in chapter 2, we cover the very principles of model quality. Basically, it's made up of different aspects, right? So accuracy, reusability, efficiency. So those are the key features. And not only that, also attestations and documentation to establish the model matches the equipment. Next, please. Next. So the model verification process is essentially making sure all these tenets of the model qualities are met. Right. Next, please. Is a giant diagram. I'm not going to go through that in details. Please look at figure 2.2 on page 18 of the document. But what it really is it breaks down the roles and responsibilities by each entity, functional entities, and kind of laid out in a logical order what each of them should be doing and what should be the delivery from each party to the next. Next, please. So we also covered EMT study use cases in the chapter 4 as discussed, just to kind of highlight some of the things, wherever you have a very weak system, wherever you have a lot of IBRs, where, areas where there could be a subsystem control interactions with other plants, when there's, especially if the system is weak and there are a lot of other plants and other dynamic devices in general in the area. Next, please. Chapter 5 in the appendixes of the document covers all the relevant topics, right? So we cover benchmarking the positive sequence models against EMT model, resourcing, how to prepare for the future EMT study needs, applicability and the use of IEEE 2000 guidance, and appendixes cover the most common terminologies that you will come across when you're taking on the EMT journey. Appendix B specifically provide references for existing EMT model requirements that various TPs and PCs has already established. Next, please. General key takeaway is this guideline help industry close EMT modeling knowledge gaps. It's not complete, it's a good starting point, and we're ready to the part 2. Provide a foundation of knowledge for new modeling requirements and practices. Provides the guidance to make quality vetted EMT models available to TPs and PCs for the purpose of reliability studies. Helps industry close gaps between the interconnection studies and what's actually getting installed in the field. Next, please. To support this journey, our end goal is to have a routine and widespread use of EMT modeling. Is the creation of EMT task force. And we currently have probably 150 plus members right now, and we will utilize a continuous feedback loop to improve, to guide our work output items. Next, please. Very quick public service announcements here. We have EMT modeling bootcamps coming up. The event's going to be virtual. It's co-hosted by the US DOE, I2X, and NERC. It's actually split into 3 sessions. In July, we're going to have 3 sessions to make sure everybody's ready coming into the Bootcamp 1, which is on August 3. Bootcamp 1 focus more on individual IBR plan performance assessment. And Bootcamp 2 in September will focus more on the system impact assessments, which is more in line with the stage 5 of the adoption that we mentioned earlier. I think that's it. Back to you, Alex.
Thanks, An. Good presentation on how the things we talked about earlier get wrapped into and worked on from the NERC side as well, through their reliability guidelines and task force and boot camps and things like that. Really good presentation. So panelists, now, if you want to turn your cameras back on and come off mute, we're going to do the panel questions for this afternoon. I will just start off with, let's see, I'll pick the hardest one. So, we heard today from all of y'all, right? One of the common themes is that EMT work, EMT study work, and these special studies, they take a little bit of time, right? They take a lot of resources and a little bit of extra time, and they're kind of in a direct conflict with the ultra fast and streamlined idea of what the interconnection process should be. So, we do see some pressure to connect IBR as quickly as possible for many different reasons that we've talked about in other series and in the industry. But how do we reconcile this difference, right? How do we reconcile the need to get IBR connected quickly and also, maintaining a sufficient quality as far as studies and model data and things like that. So that's a long way of asking. The question is just, how do we mitigate the difference in a study that takes a lot of time and resource and a process that is intended to be moving as quickly as possible. Whoever wants that can take it first.
All right, well, I'll take the first step at it, and then I'll let the others add on to it. And I will just say that at SPL, we acknowledge that we can't do these studies, for all new interconnections. That's why we use screening techniques, in particular the weighted short circuit ratio. Or, I gave an example of a pretty unique IBR installation where we required these studies as well. But I would say that it's a relatively small fraction of our queue that requires these studies when you use the WSR as your screening metric.
Thank you.
I'll add a little bit to that. Screening is important, and there's different ways you can do it. WSCR may not be appropriate in all the cases, and I think one of the stage 2 of the EMT task force report that Ong was talking about is going to dive into some of those questions of how do you choose when to do a study and what might kick off a study like that. But I think all of those are kind of a little bit dodging around the question, the fundamental question you have, which is, the stuff is coming on fast and it's requiring to be connected fast, and all of this stuff just slows us down. I think both of those are true, and the answer has to be at least partly in changing the way we resource these studies. We need to invest in training, invest in people. It's not going to get simpler or easier in the next few years. I think on the other side, there needs to be investment also in tools, in processes, and in some of the research topics that are needed. But there's no get out of this for free card. We can't just add this extra onto what we're already doing. We need more help.
Yeah, just to add to Andrew's, we really have to ask the first, why are we even connecting these devices to begin with, right? And what is the point of them not being reliably operating when we need them? So, it's a real struggle. That questions really hit home, with the work that we're doing. And one of the strategy that the EMT task force is trying to approach this is to make the EMT modeling as more accessible and more approachable, and breaking down the barriers. And so we got to attack it from both ends of the questions, right? So one is, like you said, you mentioned, it takes a lot of resources. Well, how do we make it take, less resources? Maybe automating certain things, having a really good, screening criteria, so we're not, we really focus on where we need to be, especially when we are resource constrained. So we got to make the need less, and also, make each study more efficient. So that's one of the strategies that we're going towards this big challenge, is make it more approachable.
So I will detour very slightly, just everyone mentioned screening studies or screening processes. So just generally, FPL is decided on the weighted short circuit ratio. So I guess I'll ask this directly to Andrew A, and then everyone else can join. Sorry, I picked on you. But did FPL consider any other screening methods? Was there a process for deciding on which one best works for your area, or did the weighted SCR just happen to work out on the first try?
So we have looked at different types of metrics. We've looked at, just the standalone short circuit ratio, individual plants. Obviously, you can miss things, when you have clusters of plants all in the same general area. We've looked at XR ratios as well. But no, we have been consistently using weighted short circuit ratio for quite some time. We continue to look at different ways of establishing that cluster. How many solar sites and how far out, should we include sites in that weighted short circuit ratio metric. And, we do have several people in our team that are coming up with different algorithms to do it. But no, that has been the focus for us.
Thank you. For the rest of the other two, what kind of screening methods have you all seen, just generally in use, in addition to weighted short circuit ratio, and do those work, or do they come with their own caveats?
So there's lots of ways you can screen. It depends a little bit on the type of concern you have. If it's series capacitors, there's documented ways of screening that they do, for example, in ERCOT, to tell when you need to do an EMT study because of series capacitors, and you can adapt those. There's specific reasons for those, and I think screening needs to be done with a lot of care, and I think this is probably the biggest next question in this industry is, okay, we've got our models, we've done what NERC said, we got the models, we've got some training, we know how to do a study. Now, where are we going to do the studies? And that's going to be the next big question for the industry. Some folks have the luxury of being able to do an EMT study for every interconnection because they're relatively small, or because they have the need or the resources. And so their screening for studies is going to look different than someone with a huge backlog and a huge amount of studies and not enough people. They're going to have to screen in a different way. And there are lots of techniques. There's lots of SCR-based techniques, which like I think I said in the chat, I think those are going to expire. There's an expiry date on those types of methods because as you go to 100% renewable, the SCR type metrics stop working properly. But you can also do geographic type screening. You can do sort of eyeball-based screening, looking at a transmission map and finding the boundaries of a strong system. There are some quite sophisticated screening tools that have been written, a lot more difficult to conceptually understand than an SCR, but take more account of overall penetration of renewable or IBRs in a region. So it's a bigger question than we can answer right now, but I think that I'll just leave it with the idea that this is probably the question next that everyone's going to have to tackle. It's not an easy one to answer in the chat, which is why I'm kind of dodging it in the chat.
Thanks, Andrew. It sounds like it's kind of similar to what we talked about in the interconnection session, where there are ideas out there, just like there are interconnection requirements internationally to look at for reference. There's screening methods that we can use for reference, and it really comes down to which one works best for your area, or which one works good, and then you can tailor it for your area. So I think the overall idea there is that it's going to be complex, it's going to be region specific, but we definitely need to take care when choosing a screening method, right? So thanks both. Andrews, Ong, did you have anything to add to that, or we can move on to the next one?
Well, I would just say, get involved. We just kicked off the work item on the reliability guideline. The first thing we've been talking about is, it's scoping, and first thing we started with is the screening. So as Andrew mentioned, that's the next big ticket items for us to walk through, get involved, ask lots of questions, and that helps us have clarity on what we need to tackle. So
thanks. Yeah, and if y'all participants want to get involved, you can email me or Lemitra, and we can get y'all added to either IRPS or the EMT task force to either participate or contribute or just listen in. So give us an email if you want to be joined on that, or you can email Ong also if you want to get involved with us there. The next question is, how do we ensure, we being industry, how do we ensure that the studies being conducted during the interconnection process are sufficient, as in study with the sufficient models of appropriate accuracy and fidelity? How do we ensure those things from y'all's perspective right now, and also if anything new gets added in to that complexity once we hit high penetration of IBR?
That's a $1 billion questions there. I think we gotta leverage our experience. And I would just say it's, and many of these things are based on engineering judgment. And one of the things that we're trying to do in the task force is kind of create a baseline of basically things that we've done before. As Andrew was mentioning, these are special studies today, but they will not be special anymore in 5 years from now. They'll be more commonplace. But yeah, as we come through the industry and really learn from other regions and other across the industry itself, what we've been doing, maybe it's special, but we will have at least a baseline of those, and we want to at least check those boxes, right? I think it's hard to know what we don't know yet.
I think so.
My take, and I hate to give this answer because it gives me more work, but unfortunately, I think that some of these studies will have to be done multiple times. When you're looking at a plant that's going to be connected 5 years in the future, there's certain parameters that are going to be tuned during commissioning. I think unfortunately we're going to have to do the study in the interconnection phase. We're going to have to get the as-built data, and in some cases, if there are changes, we'll have to update that study as well too. So yeah, I think some repetition is going to be necessary.
Thanks, Andrew. other Andrew? Anything to add to that? Andrew, aye.
I mean, sufficient studies. How do you know when you've done enough study?
Yeah.
It's a hard question. I think maybe just a small piece of that is how do we know our models are right? I think is an open question on a lot of these things. I know some of the NERC events that happened, there were EMT models available and they were just wrong. So EMT model by itself doesn't, guarantee that you have a correct model. It has to be a correct EMT model. And so I think there's a lot of effort going in right now, both with some of the NERC mod standards and IEEE 2800.2 towards validation of unit models, so that there's a track for model accuracy, both in parameters and in the core accuracy of the model and the detail, right back to type testing type stuff, and then another focus on validation after the fact with recordings if where possible and with site tests. So I think there's a big push towards model accuracy, which will help at least give us the tools to be able to do the studies properly. But that's only a small piece of that question, like how much study is enough study. I think what we're all trying to do is manage risk, right? That's the point of these studies, is to manage risk, and where we think that we've bounded our risk, that's the place where we bounded the risk and we have sufficient confidence in our studies, then we've done enough. But that's obviously pretty wide and kind of blurry line.
Thanks, Andrew. Yeah, I think. Oh, go ahead, Andrew.
If I may add to that, Alex, one of our strategies when it comes to EMT is kind of decouple what we have to do today from other processes that we don't have control or other unknowns, right? And do what we can today. And I think if you look at that, 5 stages, the first 3 stages will mitigate a lot of the risk, right? And even to that point, it will be a concerted push from everybody in the industry. So I personally would like to get there first, and that means we have some time to think about the answer to your question.
Thanks, all. I had a softball lightning round. So if everyone, this would be like a 20-second answer, because it's really open-ended and kind of fluffy question. But we all heard from y'all today that there's really a steep learning curve for EMT. So in like very short answer, what's your perfect vision for how we hit, how we raise the knowledge floor for EMT in the industry? Is it academia? Is it industry trainings, things like that? Yeah, what is your utopic vision for getting there?
I would say it's no one thing, Alex. It's a mix of several of the things we've already spoken about. Industry training is huge. Getting people up to speed on this, as well as investing in our people, increasing staffing. We've sent people for training, but really getting up to speed on this thing, you got to pull them off all of their day-to-day work and have them just dedicated to this for a couple of weeks as well too. A lot of us, most transmission planning departments aren't able to do that, to lose multiple planners for weeks at a time. So, that is a challenge for us in management, to see that this work is not going anywhere, and, to train our guys and, give them the time to really practice on this.
Thanks, Andrew.
I would basically second what Andrew Arana just said. I think that, the training aspect, all of those things you said, academia and all of those things are important, and resourcing, like I said before a few times. But the training piece is a little trickier than people imagine, and it's not unintuitive. You can't just take a week-long course or take a 2-week course and then now you're good. Now you've got EMT capability. It's not like that. You have to dig in. Once you're finished your course, you have to have those people that took the course now running studies. Now that's what they do. They do EMT studies now, at least a significant portion of their time, and that's how the capability is developed. It's not developed in courses. So yeah, unfortunately.
Thank you.
I agree with Andrew, both Andrews. the skills honed over time, consistent and regular use of the tool. And we can get started with learning how to use a tool, and the rest is what do you do with that skill once you learn how to use a tool. I think that's the one that will evolve over time. And as Andrew said, you have to commit a certain amount of consistent effort into it to really develop over time. But just to get started, we've got these boot camps planned. There will be more in the future. We are exploring more opportunities for this. But if everybody learn the tools first, and I think that will set the stage for the rest of the journey, right? So you mentioned the learning curve is steep, and we've been thinking about how to make it less steep, right? And that's one of the approaches to go one step at a time.
Thanks, Han. That is it for the panel session. So thanks everyone for joining us today to present and for listening in. Just to close this out, I want to pitch one more time for Ong's joint boot camp here. The dates are on the screen. If you want any more information, just feel free to reach out to us for this bootcamp series or the EMT task force or the IRPS, since it sounds like from our presenters today and from the rest of the webinar series, these aren't going away. EMT isn't going away. Special in-depth studies aren't going away. So it's the time to get started on that climb up the learning curve is now, to make sure we're all ready collectively as an industry to take on the challenges of these new studies and detailed studies once we get really high penetrations of IBR. So thanks everyone for joining. We are going to be back here on Thursday for our 8th session, which is going to be the interconnection process. So see you all in a couple days, same time, and have a good day.